Very good. All right, so we're going to pretend that this is the take-home part of the test. At one point, it was the test. This was the test. What I want you to do is I want you to spend the first 2 minutes completely on your own. No help from anybody. Don't talk to anybody. No support from anybody. Your job is to read through this, make sure you understand the problem, graph on your calculator, get your calculator set up so that you're ready to go with this. 2 minutes, we'll talk. Alright, so just let's have a quick conversation about this. We know we've got people entering the park at a particular rate, we've got people leaving the park at a particular rate, we've got multiple rate functions that we're going to have to juggle here. Is there anything in the problem that you think some people are going to struggle with? Maybe not you in particular, but others might struggle with when they see this problem for the first time. Celeste, what's something that you're looking at?
The interval that the leaving function exists on.
Yeah.
Because it only exists from t equals 12 to t equals 23.
Okay, so the park closes at 11 p.m., which is t equals 23, and people start leaving the park, not when it opens, but they start leaving the park at a different time. Does it, just situation-wise, does this make sense that that's actually what would happen? Mm-hmm. Right, hopefully no one's like going to go to the park at 9 a.m. and turn around and be like, peace out. That roller coaster's too tall for me. So you've got people coming in at a particular rate, and then you've got people leaving at a particular rate, but you're going to have to juggle different time intervals. So that could be a thing that's going to cause some problems. Anybody else see anything that might be troublesome? Myra, what else?
Maybe when it says park comes at 11, they put t equals 11.
Right, so like maybe they read this too quickly and they see that the park closes at 11 p.m. and they think t equals 11. Okay. And the College Board tends to be kind with things like that. That's not the mistake that they're going to worry about. So they're going to be like, hey, I mean t equals 23. Units are going to be a problem here. You have to pay attention to the units. And something that used to be a problem with the calculator, actually it's not a problem with the calculator, it's a problem with the teenager in the calculator, is typing those functions into the calculator. Right, just because you've got like a rational function, and so like a lot of folks weren't really sure, like, where do I put the parentheses? The nice thing is on your calculators, you've got that, it's control and then something, and it already like gives you the fraction. Control divide gives you the fraction, so you guys are like, I know how to fill in the numerator, I know how to fill in the denominator. Okay, So here's the goal. In the next 10 minutes, you working with somebody else in this room, but not somebody that you're sitting with. The goal is to complete parts A through E. Because Aaron is kind enough to be gone today, we don't have the fear of who has to talk to the North
thank
Central
God.
kids. Okay, so go find a partner. You're gonna work with them for the next 12 minutes. You're gonna get as far as you possibly can.
Over here. Over here.
Yeah, you know. You
That one.
That was me.
I'll know in a little while. Are you gonna be okay with driving the car? Alright. So what's the partner relationship here? You guys are partner? Okay, you guys are partner. If you need some help, switch the cup from green to yellow to red. Whoever's birthday is closest to today is in control.
Me.
The one.
Birthday
Still
is
you?
closest. Still it is. Oh, it is. Okay.
Alright, what's the partner relationship here?
So
at the
you
man
can
table? Okay, here you go. Here you go. The cups do the talking. Green, everything is good. Red, crisis mode.
One down.
Alright, friends over here. Let the cups do the talking. If you need any help, just switch from green to yellow to red. Red means you're in crisis mode, Lewis.
Yeah. So three. So times 3 halves. Times E of
Hold on, what's the first function? I can't see it anymore.
the
The first function is 15,600 divided by t squared times 24t plus
Divided by t squared minus
24t
2 E
24t
plus 160.
plus
plus
160.
2
Alright, and then
12.
I was writing on that.
alright, and then column on the second one. David, what's the second function?
What part do I have now?
Says G equals
Yeah, you saw that.
98, 90 over T.
Wait, you said 98 what?
890
Yep.
over T squared
Yep.
minus 38T
Minus 38t.
plus this unit check.
Wouldn't these answers have to be wrong? Like you have to know because you can't have point A 3 I don't know. It says estimate the value. For all these answers, would they have to be whole numbers because you can't have like decimals or
Great question. So when it comes to the AP exam, you go with 3 places after the decimal unless they say otherwise. So even though you're like, but this is gross, we're talking about people, decimal places with people. In terms of graphs, do they predict something like that? Okay.
That's how many people.
Over here. Just want to make sure. Your graphs look like that.
4580.
Right, maybe you're going with a different window. Like, one thing I would recommend is if you have a domain restriction, use that as your window. fact, I need to fix mine because the domain restriction should be, was it 9 to 23? Okay, and I think when I set up my graphs, I went from 0 to 23, so I'm gonna fix that.
Bless you.
Yeah.
Wait, for what? For B? I got negative 149.
Well, that's not the.
That is how quickly people are entering.
Yeah.
How quickly people are entering.
What?
Because
Same thing.
the derivative is the slope. The slope is
Yeah.
Yo.
Bless you.
Okay, Pierce, how many guys had 4,962.883? Okay, so we're good. So, like, here's where I'm thinking the points are gonna come, oh wait, 1/2, and then there's a 1.5 at the end of here. Okay, so I think the points are gonna come from probably like 2 points for this initial setup. Because you've got trapezoids of equal width, you get to do that like that shortcut process where you're like, use the first base once, use the last base once, all the other ones twice. Then 1 point for the number answer. And Ailey, how are you feeling about your explanation for what this means?
From T equals 9 to T equals 15 hours after midnight.
From T equals 9 to T equals 15 hours after midnight.
9. You put 19 instead of 9.
9, thank you.
The amount of people that have entered the park.
The amount of people that have entered the park. Yep. Is that number, right? The 4,962.883. And Celeste asked this question earlier, like, shouldn't I round this? No. Unless the College Board says to round, don't round this number. Let's just assume it's zombie day at the amusement park, so it's okay for this .883 people to be there. All right. And so the explanation would get you the 4th point, so 4-point problem. Let's just keep going. The goal is A through E. What number are we working on?
I was adding. But then I added.
Does it mean how fast people are?
Wait, that doesn't make sense. Yeah,
Because the rate at which the rate of people is. That's such a dumb sentence.
Yep.
The rate of, yes, the rate of the rate at which people enter in the amusement.
I agree with your number, I don't agree with your units.
People
I just said the rate and then
Definitely not people per second. Right, E of T is measured in people per hour, so when you look at how that's changing, it changes at a rate of people per hour per hour.
Oh, you did it.
per hour.
Okay, on part B, just for anybody that's still on that, I want to remind you of something. If you need to take a derivative, your calculator will find the derivative for you. Like, I don't have to use, I don't know, like the quotient rule. Ugh.
enter and then control enter.
Okay. Control, enter.
What?
Mother,
I don't know what's wrong too.
there we go, negative 149.760. Okay. If you want to use the quotient rule, Lewis and Giselle, of course you can use the quotient rule. Okay. $9.760 at t equals 15 hours. The rate at which people are entering the park decreases at a rate of 149.760 people per hour. I'm gonna get you on the units. Part C is a 3-point question. For part C. Evaluate the integral from 12 to 15 down to 8 prime of TDT. And how did you figure that out?
Because the derivative is basically the people who are leaving.
Yeah.
The rate they're leaving.
Yep.
Is basically decreased in the area underneath the center, but the total amount of decrease over time.
It's the average, something like that. Fundamental theorem of calculus.
Yes. Stephen, if I'm over here, people can see me, right?
No.
No. No? Oh. All right.
At least they're hearing me, sir.
And then you're staring
At least they're hearing. Great. All right, so the integral from 12 to 15 of e prime of t dt, a couple of ways to think about this. One way to think about this would be fundamental theorem of calculus. Okay, we know that E represents what again?
entering the rate of
E is the rate at which they're entering. So E prime is how fast the rate that they're entering is changing. The integral would be how much the rate is changing. E is the rate that they're entering. E prime is how fast that rate's changing. That integral is going to be what's the total rate. So you could do E of 15 minus E of 12. Right, when we were doing fundamental theorem of calculus, when that was the focus, you guys may have written the problem this way. E of 15 equals E of 12 plus the integral from 12 to 15 of E prime of t dt. This is what your fundamental theorem of calculus in like the standard presentation would look like. I want this part, so find E of 15 minus E of 12. E of 15 I can get on the calculator. E of 12 I can get on the calculator. And so what are we getting for a number here?
negative 351.
Negative 351? Palamon, you had negative 351 as well?
Yeah.
Friends over here, are we okay with negative 351? What are the units? What are the units, Palamon?
People per hour stress.
Okay, so I heard people per hour squared. What do we think about the units over here?
If he's asking anything, just people per hour.
People per hour.
Yeah.
Stephen, what do you think about units?
Right.
People per hour.
Why?
Yeah.
Because we're not really talking about acceleration. We're talking about. We're talking
What?
about people leading per hour.
Okay, right. What are the units for E?
People per hour.
People per hour. The units over here, still people per hour. People per hour minus people per hour, people per hour. All right, now we're going to get a couple of opportunities to go solo. All right, on your own, part D is a 3-point question. Give you 1 minute, read through this. If you've already done part D, move on, but part D, completely on your own. How many people are in the park at time t equals 14? I've seen a lot of close answers. Haven't seen a perfect one yet. Until... Oh, no, still not. Still haven't seen a perfect one. A lot of potential. There was something we talked about, and I said be really careful. And it looks like Lewis is the first one with an all the way right, all the way perfect answer. Keep going. And Myra's got an all the way right answer and is moving on to the next one. Oh!
Okay.
You made it sound like I just punched you or something.
Ow.
Oh! Oh, let me close this message from Miss Cooper. Hold on. That's right, because that's cute when you do that. Not at all. All right.
You talk in the garden after you these.
All right, so if I'm going to think about the number of people that are in the park at time t equals 14, I need to think about a couple of things. Number one, were there people there in the beginning?
Yes.
Were there people in the park at the beginning?
Well,
No.
No, the park was empty, so I don't have an initial condition to worry about. I'm going to start at 0. Then I need to figure out, okay, how many people entered? Well, when do they start entering?
9 o'clock.
They start entering at 9 o'clock, and I'm interested all the way until 2 o'clock. So the integral e of t dt from 9 to 14 is going to be how many people entered. That's not going to tell me how many people are in the park, though, because I also have to consider the fact that some people left. Okay, so I'm going to subtract off the integral of L of t dt, and a lot of mistakes were happening over here. One of the biggest mistakes was that not paying attention to when do people start leaving. They started leaving at 12 o'clock, and they keep leaving until 2 o'clock, and then if all goes well, you're going to get, I think it's 3,871.090. And in this case, they did say round to the nearest person, so 3,871 people. Probably 1 point awarded over here, 1 point awarded over here, 1 point for the final answer, and you only get the final point if you round it in the correct way at the correct time. Is everybody okay with this one? Okay. Definitely, I would pay careful attention to those starting values. Like we knew in the beginning it was going to be a problem. This is Exhibit A of it nipping you in the butt. All right. Let's move on. I want to see what you guys can do on your own with Part F. Part F is another three-pointer. All right, when you think you got it, call me on over. Can I get you to start driving on the laptop? The setup alone gets you 2 points. Yeah. There's a 4 p.m. that leaves a 1 hour gap. You know what a 1 hour gap is? Yep. Did you delete something? It's going to cost you a point. Don't change it. Don't change it. Good. Well, not good, but. Love it. Love it. All right, so let's move to the end. Okay. All right, so Celeste and I just had a tough conversation. This is Celeste Figueroa at Southwest, class of 2017. Sorry. All right, I want to make sure that everybody can see this. So the folks watching at home, or I can't zoom in unfortunately, there is a lethal mistake being made here. There is no doubt in my mind Celeste has a good idea. She's doing the integral from 9 to 17, and almost everybody's doing the integral from 9 to 17, because people are coming in from 9 to 17. She's integrating and she's getting 5,019. Then she's multiplying by 15 to get this number over here, which isn't the right number, and no idea where that came from.
Me either.
Okay. There is a lethal mistake. There is such a lethal mistake, and it's not just the bad multiplication over here. Whenever in the writing you link things together with an equal sign, they better be equal. You're telling a math lie. Because what you're saying, Celeste, and I understand what happened in your head, you're like, let me find this integral over here. What's that integral equal to? It's equal to 5,019. It's not equal to 5,019 times 15. The equality stops when you hit here. So you don't want to write anything after that 5,019. Does that make sense? These two parts are equal, but this guy is not equal to all of this, and so it's called a linkage issue, and all things fall apart. Okay? Now, there's also a bad thing about to start happening on the next integral. Anybody see the mistake on the next one? That's a 17.
Oh.
If you don't start at 17, what happens is these people get charged $15 to come in. These people are about to get charged $11. And what happens to the people that come in between 5 p.m. and 6 p.m.? It's free! You got fired. You're not charging people. Alright, so if
Happy hour.
all goes well, Paul, you ready for a little show and tell?
It's happy hour.
Not sure.
It's happy hour.
It's happy hour at the park on Zombie Day. Great. Come on now. Come on now. Even the document camera's like, just one more day, dude. Leave me alone. Alright, so if all goes well on part E, you're going to do the integral from 9 to 17, e of t dt. You're going to do an integral from 17 to 23, e of t dt. This guy gets multiplied by 15. This guy gets multiplied by 11. And I add them all together, and according to Polymon,
I calculated.
$104,048.165. And honestly, I don't know the College Board standing on here. Do they say round it to 17 cents? Because
Well, that's wrong.
Round the end
Round
to the nearest dollar.
oh, it does say round to the nearest dollar. Thank you for making me a better calculus teacher. Are all the friends okay? We're good? All right, so why don't you guys switch partners? I think it's time to move around a little bit. With your newfound partner, see what you can do with G, and then we're going to close out with part H. Part H is a whopper. So pick somebody smart that you're not currently sitting with. Palamon, you're going to stay where you are, okay?
Makes it down to equals.
Giselle, thank you for going over to the naughty kid seat.
Wait, is this what you say?
No. She's in the naughty kid seat. Polymon's special place. The timeout chair.
Why is the time watcher better than any seat we have?
Generate an integral equation which can be used to determine when the number of people in the park is equal to 1,000.
Oh.
Oh no. You did it again.
Oh, I was
Okay, we're looking good.
Oh.
Man, this is totally your thing. Alright, so is this part G? Okay, people enter the park from 9 until sometime t. E of t dt minus the integral, this is 12. TL of t dt. And my goal is for this to be equal to 1,000. And if that's what you have on your paper, you know exactly what I'm going to say.
Wrong.
I hear that wrong is strong. Saying wrong is strong.
You don't like it.
I don't like it. It's going to get the job done, but the better way to write this, David, what's the best way to write this?
Change the T in EFT.
Okay, but which one?
The one that's inside.
This guy up here?
No, the other one. The one
Right,
inside.
this is a specialty. This
Yeah.
is that magic value of T where everything balances out to be 1,000 people. You can't change this one. It has to be this guy over here. So E of x dx. And you want to go wild, make this L of y dy. Doesn't matter.
Whoa. Calm down there.
But within the integrand, if your function is a function of x, then you're integrating with respect to x. If it's a function of y, integrate with respect to y. Probably the more natural thing for all of you guys to do, though, L of x dx. We get this under control? All right, perfect. Now for the tough one. There's one of these on the Penguin Island problem tonight. There's going to be a problem like this on the take-home test. there's going to be a problem like this on the AP exam. How do I know? There's always a question like this on the AP exam. On the time interval 9 less than or equal to t less than or equal to 23, at what time is the number of people in the park, when's it going to be the greatest? Show the work that supports your answer. So I want you to have a strategy conversation with somebody near you, and then we're going to talk. Palamon, can you switch over to the graph?
Wait, so there has to be, first of all, EFT has to be very,
Yeah.
there's gonna be more people entering the
I'm assuming it's gonna be.
It has to be before 12, it has to be before 12. It has to be
Once people come in, it needs a lot of people.
right, because
That's the tier, and then
because before noon it's a constant. You work constantly.
maybe you're at the highest point.
Yeah.
To see how you're learning.
No, that's not even. So anytime before that.
Okay, so you're saying right over here is when the number of people in the park is going to be max. So at that intersection point, what's happening to the number of people in the park? Is the number of people in the park increasing or decreasing at that point? This point right here, the blue graph is taller than the red. So the number of people in the park is increasing at that point. What about just after that? Go a little bit over to the right. What's happening to the number of people in the park? Alright, so on your graph,
No, that's just
the number of people in the park is increasing here because the blue graph is taller than the red graph. They're entering faster than they're leaving. What about over here?
But it's still the same. It's still decreasing because
The number of people in the park is
because
right. It's not about the gap. It's that the blue graph is taller than the red graph. People are entering faster than the red. So that highest point there is not where it would be. All right, friends, if I can pull everybody together. All right, Palamon, before you do anything, freeze. Hit escape a couple times. Okay, so if I want to know when the number of people is the greatest, I hope everyone's realizing like this has to be an absolute maximum question. Right. Greatest absolute max is screaming. Carmen, what's the process we're going to go through if we're going to look for the absolute max?
You have to find out your candidate.
Okay, so you want to check out the candidate. Where's the candidate for the greatest number of people? Okay, now what normally happens in like an AP Calculus class, whether it's A, B, or B, C, intersection points start becoming really important to us, and you're like, oh, it's always the intersection point. But what I care about is this. Why is it the intersection point that we look at? Why is this the candidate? Whereas Palamon, for example, was saying that like this guy over here, where the blue graph reaches a maximum, shouldn't that be a maximum, the candidate? Why is this guy the candidate? Uh-oh. Palamon, why is this guy the candidate?
because that is the point where the people no longer, the amount of people entering is no longer increasing, which means that that is the point where the most people are going to be present at the park.
Okay, if I think about like this little slice of time, t equals whatever the heck it is, what's happening to the number of people in the park? The number of people in the park at this particular time, look at the red graph, this is how fast they leave. Look at the blue graph, this is how fast they come in. What's happening to the number of people in the park? At this time right over here, the number of people in the park increases because they come in faster than they leave. What about over here? Still increasing. Over here? Still increasing. So like number of people in the park, increases. And that's because E of t is greater than L of t. Over here we can make the same argument but it's decreases because EFT is less than LFT. Is everybody okay with that? So the reason that this guy is the candidate is that at the intersection point, the number of people in the park switches from increasing, right, going up, to decreasing, coming back down. That's why this guy's the candidate. Okay, so Paloma, what's that candidate?
Oh, good job.
15.795. Is everybody okay with the candidate? Okay, but you got to make sure that you tell me why this is the candidate. And maybe I'd want to say something like because E of t minus L of t is equal to 0. Something like that. Because E of t and L of t are equal to each other. You've got the candidate, but we're not done. Andrew, why are we not done? Okay, so we've got to have conversation about endpoints. So what are the endpoints that we're going to look at here? They gave you a really specific interval.
9 and 23.
At t equals 9 and t equals 23. Lewis, is that what you're going to say? So Miss Blakely at East End would say, okay, let's make a table. Over here, your time values. Over here, number of people in the park. We've got 9, we've got 23, and we've got this candidate over here at 15.975. How many people in the park at time 9? There's 0. Number of people in the park at time t equals 23. Not necessarily 0. Not necessarily 0. I think what's happening is we're having like real world thoughts here, like the park is closed at 11 p.m. Therefore, no one's in the park.
113.8686.
113.8686. Is that where you've got found on? So that's where's 113.8686 coming from? From the graph? The way that you're going to figure out the number of people in the park, you have to integrate. Right? You're going to have to say, okay, how many people came in the park between 9 o'clock and closing? Minus, we're going to subtract off the number of people that came in the park from when they started leaving, 12 to 23. L of t dt, and Palomon, if you could get that for me on the calculator, I'd appreciate that. So integral from 9 to 23, e of t dt, minus the integral from 12 to 23, L of t dt. We're going to get some number. What'd you get? 374.971. 374.971. Let's see if that's actually correct. So you're doing the integral from 9 to 23. Right, minus, and actually, Palomon, the parentheses there were optional. Nothing wrong with putting them, but they're optional.
Whenever 20 ends up going into the x, that's all.
Oh, okay, I get you. So minus another integral from 12 to 23. Now, this is with the other function, so f2 of x. And 374.971, everybody's okay? Not done. Not done. Why are we not done? Lewis, why are we not done? Right, at this 15.795 number, you also have to find the integral. Now, I want to do a couple of things that are going to make your life faster. Palomon freeze. Okay. Faster option number 1, that 15.795 that we got is the intersection point. We could do something clever.
Store it.
Store it. Palomon, go back to the graph. And what you're going to do is you're going to click on the 15.795, click once, it highlights, and then it's the store button, or is it the VARs button? Yeah, the VAR button. So hit VAR. var is above the 9. Var, store var, and then call it something. And whatever you're going to call it, so if you're going to call it A, make sure you're labeling it as A. A is 15.795. It shows up in bold. You know that you've done this right. Now let's go back to the calculate screen. And Polymone, I want to do this so fast, because you guys are going to have to do, no, I want to do it faster than that. Sorry, not a race. This is going to be a smart thing. What I need to do is I need to integrate from 9 to A of E of t dt minus the integral from 12 to 23 of L of t dt. And a wicked smart thing to do is use the calculator like it's a computer, like with copy and paste. So arrow up. No, arrow. Yep, there you go. So that it highlights this text, hit enter. And it copies everything down. Don't hit enter again. Go back, and where you had 23, put in A. Where you have 23 over here, put an A. David, what's
Oh,
up?
no, I was going to ask you why you put 23 instead of A there.
Why did I put? Because I was a little distracted. So, okay, careful. It's still starting at 12. And then from 12, it's the 23 that becomes an A polymorph. Hit enter. 4,324. Okay, so 4,324.637. Go back, make sure you're answering their question. Their question was, at what time will the number of people in the park be greatest? At time t equals 15.795, the number of people in the park is greatest. Now, I'm curious, how many of y'all were expecting it was going to be the candidate where you had the absolute max? So 1, maybe 2, 3, 4. Polymon, go back to the graph. We're expecting that that's going to be the absolute max. Why? Carmen, why?
Because it's the only point where it changes signs.
Okay, the word "it" kind of throws me off a little bit there, okay? What's happening at 15.795 that doesn't happen anywhere else? At 15.795, Lewis, what happens at 15.795?
There's equal amount of people leaving.
There's an equal number of people entering as leaving, but what happens at this point with the number of people in the park? It changes from increasing to decreasing. Think about a graph that from like 9 until the center section point increases, and then it decreases. What do you have at 15.795?
Oh, that's
You're going from increasing to decreasing, and that's all that happens. Is that a relative max? Yes, and absolute max, because that's all the graph did. The graph went from increasing to decreasing and does nothing else on the interval. If you went from increasing to decreasing to increasing, even for just a little bit of time, it may not be an absolute max. So you can either go with the table, and the table is your justification, or you make an argument with the graph and you say something like, from 9 until this point, the number of people is increasing. From this point to 23, the number of people is decreasing. That makes this point a relative max, and because it's the only extrema, an absolute max. Everybody okay? You guys have 2 homework assignments that I need to get from you. Make sure I get both of them, please. I'll just collect them on the way out.